Counting sort never compares two elements directly. When every value is a non-negative integer in a small range, we count how many times each value appears, then write the sorted result from those counts. The work splits into a count phase and a build-output phase. Use counting sort when keys are integers in a known range 0 through k-1, and k is not much larger than n. It is stable if we fill the output from right to left. Skip it for general data, floating point keys, or huge ranges where the count table would waste memory. Here is our input array. Each cell holds a value between 0 and 5. We allocate a count table with one slot per possible value. Scan the input left to right. For each value, add 1 to that value's counter. After one full pass, every slot tells us how many copies of that value we saw. The frequency counts are done. Next we prefix the count table in one left-to-right sweep. Each bucket stores how many input values are strictly smaller than that label. The prefix row now marks where each value will be written. Reveal an empty output buffer and fill it by scanning the input from right to left. We scan from the right so equal values stay in order. Input index 7 is 3. Use 3 to index the prefix row. Bucket 3 reads 7, but output slots are 0-based, so we write 3 at output index 6, that is 7-1. Decrement bucket 3 from 7 to 6. Move left to input index 6, value 0. Bucket 0 holds 2, so place 0 at output index 1. Decrement bucket 0 from 2 to 1. Input index 5 is 3. Bucket 3 reads 6, write 3 at output index 5. Decrement bucket 3 from 6 to 5. Input index 4 is 2. Bucket 2 reads 4, write 2 at output index 3. Decrement bucket 2 from 4 to 3. Input index 3 is 0. Bucket 0 reads 1, write 0 at output index 0. Decrement bucket 0 from 1 to 0. Input index 2 is 3. Bucket 3 reads 5, write 3 at output index 4. Decrement bucket 3 from 5 to 4. Input index 1 is 5. Bucket 5 reads 8, write 5 at output index 7. Decrement bucket 5 from 8 to 7. Input index 0 is 2. Bucket 2 reads 3, write 2 at output index 2. Decrement bucket 2 from 3 to 2. All positions are filled. The output is sorted, and duplicate values kept their original order. Tiny example, input is 2A, 1, 2C. In the input, A comes before C. Place right to left, output is 1B, 2A, 2C. The 2's stay A then C, still in order. Place left to right, output is 1B, 2C, 2A, C jumped ahead of A, same numbers, wrong order. Both scans still give 1, 2, 2, the values stay sorted. Left to right does not scramble the digits. Stability is about equal keys, right to left keeps duplicates in their original relative order. Let n be the array length and k the size of the value range. Time is order n plus k, 1 pass to count, 1 pass over k buckets for the prefix, and 1 pass to place n items. Space is order n plus k for the count table and the output buffer. Define counting sort with the input array and range size k. Allocate the count table with one extra sentinel slot. Loop over every input value. Increment the counter for that value. Prefix step, turn frequencies into ending positions. Each bucket inherits the total count from smaller values. Allocate the output array. Stable placement scans from the end of the input. Read the current value. Move that bucket's right pointer one step left. Write the value into the output at that index. Return the sorted output.